let's do generate a C++ hello world example with dev container set up for Ubuntu in VS Code. We can generate. Let's get more. I don't even have to spell stuff right in ChatGPT. It's amazing. All right, so we're going to grab our dev container file. First off, we need a little .dev container. Dev container. JSON.
Derulo.
JSON Sovin.
Let's see.
And then Docker file. Nice. So we do that. We got a little test CPP. We'll worry about that in a second. Now I just need to get the container open. So, first thing would be to really, never mind. Reopen a container. It's got to do its magic for a second. Got to start Docker. Then the CPP file is going to look like this. And go over this while Docker is starting in the background. Yeah, what the heck? Yeah, what the heck? Why did it ask me that? Hold on. Something's off here. Reopen and container. Yeah. Why are you asking me to?
Okay, I'm locking in here.
Docker container, Debian front end, no backend. Move, install, workspace, VS Code.
Okay.
I'm just going to be like, it's asking me to configuration.
I don't like this.
Docker file, build Docker file. Okay, so
yeah,
there you go. Sometimes there's this weird configuration thing that ends up happening. Why is it doing that? It's like literally doing it still. Did I save it? Oh, the Docker file also has to be different.
I missed the beginning. Why is the Docker file to be different? Because for VS Code to expect certain things.
Because ChatGPT told me to change it.
Okay.
Hold on. Why is it doing that? This happens to VS Code. Doesn't see a full dev container. I probably spelled something wrong. Stand by. .dev container. There it is.
There we go. That would make sense. Rachel, your model's up. Your page is up.
I did it here again too.
Oh.
There we go.
Oh, yeah.
Aha! Smarter than the machine. There we go.
Oh.
Okay, so now it's working its magic. I have 8% battery. It probably last till the end of this session.
Dangerous game.
Come on, dev container. But downloaded. All right. So the C++ example, why we're doing that is this example. I'm going to point out some semantics in C++ here. So, in Python, when you create a function, you did like def and then the name of the function. In C++, it's a little different. You have to specify the type of the function and then the name of the function. And then when you do these these parentheses, that means it's a function. And then you do for, everything's white space sensitive in Python. So like, the tabs basically define what's inside of a function. In C++, that doesn't matter. All that matters is actually just the curly brackets. And then this is the equivalent to print. We can talk about that in a second. And then this is just a return function. So a lot of the skeleton's the same, but it's slightly different in terms of the specificity. And that really gets like the lower level pieces of the programming language. Let's just slow that. See plus extension. So you get syntax highlighting. Okay. So hello world. Terminal. We go here. Print. Okay. So we have our test.cpp. I think it's having me do main.cpp, and then it's having me compile with GCC. So we'll talk about that in a second. I'm just going to rename this main.cpp. You don't have to rename it. You can compile anything, any name. Int.main though is a special function that usually it's the equivalent to the init function in Python. It basically says if I run the script, start with that function. Start by running that function. So we are going to do this. This GCC is a compiler for C++. There's also Clang, which is another popular compile. There's Visual Studio compiler for Windows. Main.cpp is the name of the C++ file we just made. -o says I want you to output the compiled binary of main somewhere. So if I in this case I just left it in the same directory. So hello here. This is a binary file that was compiled from the source code of C++. And then /hello just means, hey, run that file in this directory. So when I run it, all it does is print out hello, is print out what we have here. So I know there was some context there that I was giving you. That's, basics of C++. There's a bunch of other stuff that we'll layer on over time. But okay, so we have the main CPP file. What are we looking at here? So syntactically in C++, there's this thing up top that we did. This hashtag include is a lot like import, where we're importing a library. This IO stream library is an input-output stream library that's a part of like the standard library of C++. And so by adding that in, it allows me to use this fancy syntax here, the library of that syntax. Now this is really weird C++ism outside of the print function. A lot more of the code looks normal, but with respect to the print function in C++, it looks a lot different a lot of times. We tend to call this instead of importing a library in C++, we call this a pre-processing directive. I'm going to write that out. And this is the comments. Flat just comment instead of hashtag for C++. This is pre-processing directive. So you could build a library, compile it somewhere else, or even have source code somewhere else and import it here and like compile it, or like just use the shared object or like compiled object through the pre-processing directive area. We'll talk about that later. Standard entry when you run a binary file. All that makes sense so far? This is kind of interesting form factor. I left you guys partially on the screen over here so I could see it.
Yeah. Have we talked about the importance of C++ and why we're moving? Have we talked like the basics of C++, like why we're moving towards it?
We did way back in the day,
cool.
But
okay.
The basics here are C++ is a compiled language, and Python's an interpreted language. Compiled languages always run faster at runtime, for the most part. Interpreted languages run slower at runtime. Compiled languages usually are statically typed, which typically means you are prescriptive of the types, which helps you basically run faster at runtime because it doesn't have to check in the compiler or interpreter what type am I using, an int, a double, a boolean, etc. That's all kind of handled up front and specified up front. And then also C++ in particular of compiled languages allows you to do a little bit of low level memory manipulation to prevent memory lockups. So like if I were to use Java or another language that didn't have that capability, you could fill up the RAM for that's allowed the amount of RAM that's allowed for the application to run, and it may not release the memory until that is full. That stack or heap of like memory allocation is full. And so you could have like kind of a suspense in your program while it's like erasing a bunch of memory and then releasing it. And then it releases it. And then you can start the program again. So it might be like executing, stop, and then start executing again. And so why that's bad for aircraft is if I'm sending like, commands at a certain rate or something, or trying to get messages at a certain rate for real-time applications or pseudo real-time applications, and I stop in the middle of execution, now the autopilot's not getting any commands for a few seconds, or now, I'm not receiving sensor feed for a few seconds, and it causes delays and issues that way. So that's why C++ is generally preferred over some of the other languages for that purpose. Makes sense? You probably already knew that, Justin, but just, fodder for the video, I guess. So let's give you a little bit of like syntactic, feel for C++. So first I'm just going to do another function, and I'm going to make this a math function. And basically, let's do an add function, right? So primitive int, add like that. And it's going to add int type A, int type B, and it's going to return A plus B. You got to have a semicolon after all the non-functional function lines in C++. You might even have to have it after a function, but it didn't yell at me syntactically. And you have to specify the types of everything. So the type of returning to the function goes to the left of the name. So that means the return type of this has to be an int, or you'll get an error. And then A and B both have to be ints. And so if you try to pass a non-int into the function, you get an error. Whereas in Python, it might let you get away with it. So if I come up here into my main function, right, and I just say, I want to do, int C equals add. I do 1 and 2. And then I return C. And then I do a little compile and run step here to recompile it. Oh, there's an error. Why is there an error? Was that maybe it has to be declared before?
It does.
Or do I have to declare it?
No.
Yeah.
Right
Okay.
yeah.
Stupid C++, B and C++. All right.
Yeah.
So you basically C++ is going top to bottom because of all this efficiency with the compiler. So it needs to have it basically declared or known that there's a function there before it can actually like placehold it in the compiler. And then so we compiled it and now we run it, and voila, we got 3 because we added 1 and 2. So, we're about at time, but that's essentially how C++ works. Similar to Python in a lot of ways, but different, semantically as being an object-oriented language with procedural programming. But it's different in terms of the type specification. So you can get really complex with types, with classes and structures and things that we haven't talked about yet that we'll kind of get into in future lessons. But in general, this is kind of what it looks like. Any questions in the last minute we have?
I'm all good. Rachel, do you have any? I think it's super important. Yeah. Oh, we might have lost Rachel right then. It's important to know like why we need to have this info C++, right? Because Rachel probably knows this. I don't know if Justin does, but the aviation stack is going to be written all in C++. So we're going to be starting to move from Python to C++.
Okay.
So learning this is going to be super valuable for us moving forward. And also, Ron, if we have time, maybe a class for them on like how you can tie Python to C++, maybe the differences directly compared between the two of like syntax. How to like move code over might be.
So I agree. We should talk about that, but we have to talk
later.
about pointers and references first.
Ooh.
Pointers, references, and pass by value. and stack and heap first, which I kept you guys out of, but that's kind of like the core of C++. Um, and smart pointers and all that stuff. So that's what we'll kind of get into in future lessons. Um, I didn't have any of that in here. This is literally a pass by value, which you probably don't even know what that means, function. So references. We'll get into that in the future. Awesome. All right, guys.